It all started with a simple idea I had about how to make my studio easier to operate. At the end, I spent more than 1,000 hours, lost a lot of hair, but developed the ultimate MIDI pedal.
The Magnetics My Dynamite.
It all started with the Korg D1 cheap piano with MIDI out, which allows me to play my synth with a good quality 88-key keyboard. Unfortunately, it has the same shortcoming as a lot of other digital pianos, which means it has horrible MIDI implementation. It always outputs on channel 1. This can be changed in the settings, but upon reboot, it's always back to channel 1. So starting with this problem, I started to think about a MIDI pedal that I could develop for that. So the simple idea was really easy, just a little box that would change incoming MIDI and send it to another channel. It's quite a simple project. I would just need a microcontroller, a display, and a couple of buttons. When I was starting the planning phase, I realized that there's much more than can be done with MIDI. Why just do a simple channel changer when I could do so much more? So after all, MIDI is a very simple protocol. It's just 3 bytes. If you want to know more about MIDI, I have a separate video on the Magnetics FS404 where I talked in detail about how MIDI works. The project changed drastically, and instead of having a simple channel changer, I decided to basically design the ultimate MIDI pedal. So in order to do that, I needed to change a couple of things in the original design. First of all, the microcontroller. I won't go too much into the details of how microcontrollers work, but basically with an 8-bit controller you can send MIDI, you can receive it, but there are a lot of limitations, such as the amount of different ins and outs you can have. For example, it's almost impossible to use USB at the same time as MIDI. 8-bit microcontrollers also have very little headroom, so it's hard to add a real-time OS, which is going to be very useful. I'm not going to go over the implementation details, but basically instead of having just one loop, I can have a lot of processes going at the same time. So let's say, for example, send the MIDI tempo and at the same time receiving MIDI and changing it at the same time. It's very easy to do when you have an operating system, but if you don't, it gets really tricky. So I wanted this to be absolutely future-proof. So the first change was the microcontroller. If you're watching this video, you probably have experience with synthesizers, and you probably had that synth I know I had, where it was awesome. It had the greatest functionalities, but unfortunately it had this tiny screen with only 2 or 4 or 8 characters. It's simply not good enough for a project that should last a long time and be quote-unquote the ultimate MIDI pedal. So I decided to replace that with an OLED screen, 128 by 64 pixels. It's plenty to display a lot of information. A good UI needs good buttons, so I also added 2 rotary encoders with push buttons. At the beginning, I wasn't really sure how I would use the push functionality. Now, with hindsight, I'm really happy I have them because it helps me with a lot of shortcuts. We'll talk about that later. The last addition that I was able to make thanks to that more powerful microcontroller is the USB. So instead of having just one channel of communication, we now have 2. So the USB will have 3 main functions. The first one will be to charge the pedal. The second one would be to update it. I've made a very simple updater. We'll talk about that a little bit later. And the third one is to send MIDI as a device. It was really important to me to also have USB MIDI, so that's an addition that I've made later in the process, but from the beginning I wanted to have that in the pedal. So now that I had all the specifications in mind, I started with making a minimal version of all the working parts, so sending MIDI, receiving MIDI on the prep board. The main goal of that prototyping phase was to test all the hardware that I had, so test the screen, test the encoders, test that everything can work together. And so I got working on it, sending MIDI, receiving MIDI. I have a little story regarding this phase. So I was testing MIDI in. As some of you probably know, when you send MIDI, it's a simple electrical signal that you send out at a baud rate that is defined. But when you receive MIDI, it's a little bit more complicated because you don't know at which voltage the signal comes in. You have to use what's called an optocoupler. Optocouplers take a signal and reproduce it with the voltage that you want. Optocouplers work really, really well, but something happened to me which may be a lesson for anyone who's doing kind of engineer work. So I start to test the optocoupler with my Volca FM synth. I use the Volca FM2 all the time for my projects because it has MIDI in, MIDI out, and a sequencer, so you can loop something if you're testing. So I test the MIDI in from the Volca FM and I receive garbage value. Instead of receiving the note, I get the same message over and over again. This is not a big issue when you test things. Instead of assuming that the device is faulty, you try it with another device. So for me, it was the UM1 cable from Roland. And I get garbage value again. Now, my mistake was not noticing that it was a different garbage value, and it sent me into a crazy spin. I analyzed everything about optocouplers because it didn't work. So I went really into a deep dive of studying the whole optocoupler thing. And long story short, after literally weeks of debugging, I even bought an oscilloscope specially for that. At the end, I'm happy I bought it. So I make all these tests about the optocoupler to see what's wrong with it. And at the end, I just realized that the reason why I didn't get the note on the Volca FM was because it sent MIDI clock all the time. And the exact same thing happens with the Roland cable, except it sends an active status message. So it's a status byte all the time. So I guess my advice here would be don't just test with two devices before going into a crazy rabbit hole regarding optocouplers. First, check if your devices really have the behavior you think that they have. After confirming that MIDI in, MIDI out, and MIDI USB worked well, I had a basic idea of the whole structure, and that's when I decided to add another MIDI out. So I had one UART free, and I decided to add another out, and of course it's all fully configurable within the pedal, so you can send your left hand to out and your right hand to out too, for example. Same thing with MIDI Transpose, etc. We'll talk a little bit more about that later. Now that I defined the hardware that I was going to use, it was time to start building the pedal, and so thinking about the architecture. And to start doing that, I implemented the first function, which is MIDI Tempo. This is another thing that I really wanted to have in my studio because I have a lot of MIDI devices, and on their own they work great, but it's really hard to make them work together. So I wanted to have a master MIDI tempo where I could send start and stop signals as well as send the MIDI tempo to the whole device. The reason why I started with MIDI tempo as opposed to changing the channel, which was the original function that I wanted to implement, is because sending MIDI tempo is actually trickier than it seems. So you have a lot of devices which have problems with sending MIDI tempo, and now I understand why. So basically, MIDI tempo, you need to send 24 ticks per quarter note. So for 120 BPM, you need to send one click every 20.8 milliseconds, and it needs to be very accurate. And so the reason I started with MIDI tempo is because the whole architecture should be geared towards not polling. So polling means, for example, if you receive a MIDI data, you will check if you received something, and if you received something, you will do something about it. And that is too slow for what we want to do with the MIDI tempo. You can do it with just the MIDI tempo, but when you start to add other functionalities like MIDI transform or the arpeggiator, oops, did I just spoil one of the 3 new effects that will be in the next version? Like and subscribe to find out. So the MIDI tempo function pushed me to use a real-time OS. So it's a very, very light operating system, which allows me to handle a lot of different tasks at the same time. And so that's the reason why all the effects can be used independently and at the same time on the pedal. So this is made possible by using interrupts and FreeRTOS. So interrupts basically, instead of having to poll every time and ask, are you done with that? Do you need to send anything? The thing itself tells you, hey, I'm done with that. And so you can reply to it directly. If you do things that need really fast in-time processing using interrupts and a scheduler. It's a lot of work at first, but down the road, it's totally worth it. At that point, I had one working effect and ways to test the other, so the USB and the MIDI out. So I thought it was a good time to graduate from doing everything on the prep board and having an actual PCB. I already had 2 prototypes on the prep board and they were getting bigger and bigger, so it was just easier for me to have everything in an enclosure, even though that first PCB prototype is very different to the end product. We'll talk more about that. The idea for the first PCB was quite straightforward. I don't like when USB ports are directly on the PCB. I prefer when they're panel mount. So I had the USB panel mount as well, the on-off button, just like that. So connected through wires to the PCB. And on the PCB itself, I had the screen, the 2 rotary encoders, and then all the other elements that I needed. So that's the optocoupler and all the resistors and ferrite beads, etc. I laugh a lot now when I see the crooked screen, but I didn't laugh at the time. The reason why it looks like that is simply because since both the PCB and the rotary encoders are on the same PCB, if you get the slightest shift anywhere, the screen is going to be all over the place. This is of course something that I fixed for the final product, and I'll talk about the solution that I found later. But for the time being, that's how the pedal looked like. The next rabbit hole I fell into was regarding the etching of the pedal. I spent so much time researching all the techniques in regards to etching a pedal that I will do a separate video in the coming weeks, so please subscribe to see it. So long story short, since there are a lot of buttons, I wanted to have some text on the pedal. Now, I simply love how bare aluminum looks, especially when it's been nicely polished. So I didn't want to settle for a decal or any kind of paint, and the obvious solution for me was etching. A method that you see a lot of online are people using their laser printers to make a mask. Unfortunately, I had the wrong brand for that. Apparently, Brother printers are notoriously bad for the job, and I was able to confirm that. I tried multiple times, but the mask just wouldn't take. So for the time being, for that first version, I decided to use a decal and crooked screen. But for the final version, I actually bought a laser engraver, and the solution was to spray the pedal, then take out the mask, so a negative of the image with the laser, and then I was able to engrave it. Once again, I'll do a detailed video on how I did that. I experimented with 2 main methods of etching, which I will call chemical etching and electrical etching. And for this particular pedal, I decided to settle with electrical etching. A special shout out to Whycann, who helped me with the design of the pedal. So if you enjoy how it looks, please go check his art. I will put a link in the description. Now that I had a prototype that I could actually take to my studio and test with actual gear, it was way easier for me to both add new effects and help making the ones that I already developed better. So the functionalities are one thing, what the pedal can actually do, but the way you interact with it and how easy and intuitive it is to use is very, very important for me. So even though this prototype didn't have a straight screen and it didn't have the cool etching that I would later achieve, it was great for me to have that first prototype. And so with that, I started to develop all the different functionalities that the pedal currently has. So here are all the functionalities that are now in the pedal. If you watch this video in the future, there will be a playlist so you can see all the functions that exist at the time you've seen this video. But for now, we have the MIDI Tempo. So let's start with the on-off, simple on-off button, but it's really practical when you want to send a start signal to your whole studio. You can just use the on-off and then change the tempo with the value button. And if you press, so if you don't press, there's increments of 1, and if you press, it's increment of 10. And then you can select and change to target. So target, you have the choice between out, out 2, out 1 and 2. So these are here. You can send it through this one, or both at the same time. Now let's move to MIDI Modify. And for MIDI Modify and the order, since there's different modes, you can switch by pressing select. We'll talk about that. So you have the first mode is send 1, send 2. So you can send the incoming into either art 1, art 2, it's the same as before, or split. So split means that send 1 will be sent to out and send 2 will be sent to 2. But split has also other uses. Afterwards, we'll talk about that. And so you can send the MIDI channel to either 1 or 2 channels. And once again, on off here. And if you press select, now you have the low and high mode. So it's basically a split mode where your left hand is going to play one synth and your right hand is going to play another synth. And so you can decide which channel low will play to and which channel high will play to. So in this example, I have low on channel 12, high on channel 15, and then the split is C4. So when is the limit between one hand and the other. And so you can switch by pressing select, either sending the whole keyboard to 1 or 2 MIDI channels, or have your right hand and your left hand play different things. And now the change in velocity. So you can change the speed you're playing at. So in this mode, we can make it louder. Once again, if we press, it's going to be increments of 10, or we can make it quieter as well. Now, if you don't want to change the velocity, but you want to have the same velocity all the time, you can press the select button, and now you have the fixed velocity. So from 0 to 127, you can send at a fixed velocity. Now let's move to MIDI Transpose. And MIDI Transpose has, once again, 2 different modes. So you can simply, as always, on off button to turn the effect on and off. And as I've said before, all the effects can be used at the same time. So the first mode shifts by semitones. So if you want to have here, if you press, you get 1 octave every time. So if you want to have thick basses, you can do -12 semitones, -7 for a fifth, -5 for a fourth. If you don't want to count anything, you just press this button, and now you have MIDI Transpose with the scale. Aeolian means major. You have all the modes for you music nerds out there. You can choose your mode, choose your interval. So it goes from an octave down to an octave up, and you can have 6th, 5th, 4th, and 3rds. And you change the root note. And so with the root note and the scale, all the notes that you will play will be in the scale. And you can choose to either send the bass. This is something that you also have with the shift. You can send the bass or not. So for example, if you shift by an octave, you can decide to simply shift your whole keyboard an octave and not hear the original sound. So that would be send bass no. Or if you want to have both sounds, send bass yes. And then we have the settings. In the settings, we have the start menu. So when you turn on the pedal, which menu will be used. If you send USB MIDI, so everything that will be sent through either out or R2 will be sent to the USB as a device. You can use that to play a VST instrument, for example. The contrast of the screen. So if you play at night, you can have very low contrast. I usually keep mine at around 60% because it's quite a bright screen. MIDI through. So MIDI through means that everything that comes through the USB, the MIDI in, will come through out and out too. Or you can choose USB through, the same things that come in, come through the USB. And MIDI filter. So MIDI filter is something that I added at the end of the development cycle of this version, because I realized that when I had MIDI through on, and everything is connected in my studio MIDI wise. So when I send something, it would reverberate through the pedal. So what I just did is here you can ignore all the channels you want. So for example, if you're sending using other synth on the other channels, you can mute them, and here you can turn MIDI filter on, and all those parameters can be saved by a push of the button, and now it's saved. There's a lot of different ways to use all the effects, and since they can be combined, that's even more different possibilities. But here are a couple of ways I personally use the Romagnetics My Dynamite. So the way I use it when making music is mostly to play two synths at the same time. I really like layered sounds, but that's another way. Right now I'm playing it using the split function, and on my left hand I'm playing the Korg Volca FM on the bass, and on the right hand I'm playing the Yamaha Riff ACP, so I get this very nice split between the bass on the left hand and the melody on the right hand. So here in tempo mode, I use the pedal to start and stop, and also to change the tempo. Now, changing the tempo is not something I do a lot, but I was really surprised on how much I'm using the start-stop function. It's also very useful when you use it with a looper pedal which has MIDI. I'm using it with the Boss RC500, and it's a great pairing. I mostly use the pitch shift option of the MIDI Transpose to octaves lower and fifth also. So for octaves, it's mostly for bass, you get a thicker bass. And I use the fifth interval quite a lot with melodies. It's quite fun to experiment around. For the MIDI Transpose, I really enjoy having all the different modes. So sometimes I will play something with a third up in Dorian, and I will see if it works for other modes. Now, if you don't really know modes, the setup that I really like is you put it in major or minor. So major is Ionian and minor is Aeolian. And you play basic triads with the fifth down, and if you do it, it will give you a very jazzy sound. Now, I personally don't play Mozart on my Korg Volca a lot, but the USB functionalities allow you to record everything that happens in your studio on your computer, so you can use it with your DAW and you can trigger your VSTs, and I think it's a great functionality as well, and I personally use it a lot. Hey, it's me from the future, and I noticed that there were two very important things that I forgot to talk about. So before wrapping up, the first thing is the battery. I personally love when a piece of gear has a battery, because I like to take my synth out in a while, and so for me it was evident that the Romagnetics My Dynamite also needed to have that, so I added a pretty big battery. Another very important aspect of the pedal is repairability and durability. The whole software is open source, and the hardware has been changed a lot. I only talk about one prototype, but actually, as you can see here, there were multiple boards. Even if the pedal worked well with the first version, the goal was really to have something that can be swapped out really easily, and that's the reason why I made it smaller and smaller. And it's at a point now where every part can be swapped out and changed, and I will help you repair, so it's absolutely repair friendly. I think that every device should be easily repairable and also future-proof, so that's my little contribution to that philosophy. And so here we are, from this proof of concept to the final Romagnetics My Dynamite. There's more than 1,000 hours that went through this project. It was great, but it's not finished for me. It's future-proof, as I said. I spent a lot of time making the test harness and having an architecture that could handle a lot more effects. So I would like to know, please tell me in the comments which effects you would like to see on the pedal, and I will see you for the next version.